Okay, so here we go. So, number 15. There's a lot going on in this problem. All right, so let's see if we can kind of parse out what's going on here. So we've got an arrangement on an air track in which a cart is connected by a cord hanging to a block. The cart has a mass of 0.6 kilograms. If we can cool the side conversations, that would be good. Let's see, its center is located initially at xy coordinates negative 0.50. So I'm assuming that they're, oh yeah, here. So our origin is here. So here, let's call this x1, and it gives us the coordinate of negative 0.5, right? And then the y coordinate is 0. Sloppy notation there because I'm using x. I probably should use r, right? Because we're doing two dimensionals. Is that going to mess anybody up? All right, let's use r. Let's use r. Everybody okay? So that's the center of mass 1 initially. All right, let's see. Block 2 has a mass of 0.4 kilograms. And its center of mass, we'll call that R2 initially, is, let's see, it's at 0, negative 0.1 meters. All right, the mass of the cord and the pulley are negligible. The cart is released from rest, and both the cart and the block move until the cart hits the pulley. The friction between the cart and the air track and between the pulley and its axle is negligible. In unit vector notation, what's the acceleration of the center of mass of the system? All right, so this one is a little bit weird because the pulley is actually exerting a force. Okay? There are actually two forces here. Gravity's pulling down, and the pulley's pushing up and forward, right? Because if you imagine the string wrapped around the pulley. Okay, so that complicates things a little bit, all right? So let's not worry about it, okay? Let's do this. We're trying to find the acceleration of the center of mass of the system. So let's find the acceleration of the two objects individually. You guys agree that's a thing we could do? Okay, so let's do this. So in order to find the acceleration of our system, so the acceleration of the system should be the net force on the system over the mass of the system, right?
Yes.
So the net force is going to be just gravity on this thing, right?
Yes.
Did you say that, like, wait, which one is S? Or is that the system?
S is system.
Okay, didn't you say that the pulley exerts a force, though?
So,
All right, so I probably shouldn't have said that because that's gonna confuse you guys. So
this is the blob, right?
do you guys agree that we've done problems like this before, the amorphous blob problem?
Yeah.
All right, so for a minute, let's solve it like an amorphous blob problem, okay? And then I don't think we even have to. Does it ever ask you for the force of the pulley?
No, you don't.
No, but we can find it, and that might be a worthwhile thing to do. Okay? So, but before we get there, we're going to solve this just like an amorphous blob problem. So, I'm going to get rid of some of this red if that's okay. It's not going to work. All right, whatever. Okay, so the force of gravity on object 2 is 3.92 newtons, just 0.4 times 9.8. So the net force on our system is 3.92 newtons divided by a total mass of 1 kilogram. So you get 3.92 meters per second squared, right?
Yep.
Good? Everybody good up to here? All right, now, the way that we explained this before when we did this as an amorphous blob problem was we said that the pulley serves to change the direction of this force, right? So the idea is the acceleration of object 1 is going to be 3.92 meters per second squared horizontally, right? And the acceleration of object 2 is going to be 3.92 meters a second squared vertically, so negative j, right? Make sense? So, the acceleration of the center of mass should be the acceleration of object 1 times the mass of object 1, plus the acceleration of object 2 times the mass of object 2, all divided by the total mass. Follow? So now we're just going to do these. Just make sure you keep track of your directions, you know, your I's and your J's. Make sense? So let's plug in our numbers. Am I going too quick? Are we good? Okay, so acceleration 1 is 3.92 I times the mass of 1 is 0.6, plus acceleration 2 is negative 3.92 J times the mass, which was 0.4, all over our total mass, which is just 1 kilogram. And that gives you the answer that was on the sheet. Notice if this wasn't 1 kilogram, like if it was 2, then you just divide this by 2 and divide this by 2, right? You just divide the two components. Everybody good? Any problems? Okay, so that's part A. Part B wants to know, so that was part A, we just got that. Part B wants to know what's the velocity of the center of mass as a function of time t. While I answer the phone, what's the initial velocity of the center of mass? Hello, is Miss Harker? No, do you want me to run them up? Yes, do you need them right this moment? Okay. Gotcha, yep, bye. Josh, you said you got this one right, didn't you?
Yeah.
Would you hate me if I asked you to run something with Mr. Hernandez really quick?
Oh.
There's a sixth one somewhere.
I got this one too.
No, you're fine. I'll get it. Number 5. Where's number 6? Oh, I know. It's on my demo. Tell him I'm sorry I didn't return his
No, it's you. No, no problem.
Thank you so much. All right. Okay, so velocity of the center mass. What's the initial velocity, you guys? 0, right? So VF equals VI plus AT. So the velocity at time t is initial velocity, 0, plus acceleration times time. Cool? Make sense? All right. Then it says sketch the path taken by the center of mass. Well, look, your velocity is let me write out what the answer gives you. 2.35 I minus 1.57 J times t, right? So, do you agree that the angle is not going to change? Right? No matter what t is, your x and y components are always going to be in this proportion, right? So I think the center of mass is just going to go kind of this way with a slope of negative 1.57 over 2.35. So the center of mass just goes in a straight line. Yeah, Sebo.
Now, how did you get to 2.35 minus 1.5 J?
That was this. This was the acceleration of our center of mass, and then just times t. Is that a genuine all right, or a... Everybody good? Yeah?
So it doesn't matter what the masses are, it's always going to go the same line.
As long as your forces are constant, yes. If you had some sort of like variable force of friction or air resistance or something, then that would complicate things, but... Actually, I wonder if... I'm not sure in that case. Okay, are we good? Did I solve for D, the angle? It's just, so your velocity at time t is that expression I had up there, right? So your x component is 2.35 t, your y component is negative 1.57 t, and you're looking for the angle. So you just trigonometry it. Good, you guys? Thank you so much, Josh. Sorry to have you running errands. That was not cool. All right, you can fold my laundry and get me a coffee. All right, everybody good? All right, let's do this. This is a question that I kind of wish I'd put in here. Could we find the force of the pulley? So let's think about this. We found the acceleration of the center of mass, right? So let's write this out. So here's what we know. We know that the acceleration of the center of mass is, what was it, 2.57 I minus, is that right? No. 2.35, sorry. Oh, why does this keep doing this lately? 2.35 I minus 1.57 J meters per second squared, right? Good? So couldn't we find the net force acting on the center of mass just by multiplying by the mass of the system? So the mass of the system is 1 Newton, right? Oh, so that's 2.35 I minus 1.57 J newtons. Now, what forces act on the system? Gravity. So let's see. The net force on the system should be the force of gravity on cart 1 plus the normal force on cart 1. What happens with those two guys? They cancel each other out. Plus the force of gravity on mass 2 plus the tension force, which is internal, plus the force of the pulley. Does that make sense, guys? So we know the net force on the system is this. I don't know why I changed. I should have just left this as COM. Right? So I know the net force on my system, on my center of mass. I know force of gravity too, so you can certainly find the force of the pulley just by doing some vector subtraction, I guess it would be, right? Follow? Questions? Cool. All right, so that was 50.